Hello, my name is Mr. Julius Collier, and today I am going to be giving you a quick 4-minute lesson on how to draw the degree and radian measures of the unit circle. Now, I know a lot of you are thinking, oh my gosh, the unit circle is the end of the world, but fear not. Unit circles do have their uses, and one of the main for you, it's going to be probably the SATs, ACTs, some form of test taking. And a beautiful story this summer, I actually had an SAT class where I taught the students. And one of the problems stated, let's say 0 is less than or equal to x is less than or equal to 90, where the sine of x equal 1. Now, that first day, not a single student got it right. In fact, all the trig problems, everyone just skipped it. After a week, after I showed them the unit circle, about 3 or 4 students got it right, but it still took them about 3 to 5 minutes. And then I thought to myself, how could I be so naive? The best way to learn math is by practice. So for homework, I had to memorize the unit circle, and voila, a week later, every single student got it right in a matter of 30 seconds. They thought to themselves, oh wait, x is between 0 and 90. That's the first quadrant. Now, in the first quadrant, the entire unit circle, x correlates to cosine, and the y value, the y coordinate, correlates to sine. So, where is sine, the y coordinate, 1? Well, that's only at one point on the unit circle, 0, 1. And what degree is that? 90 degrees. I switched it up to see if they got it, and they absolutely nailed it. I said, where is sine equal to 1/2? They all got it, 30 degrees. That being said, let's hop into the lesson. It's been 2 minutes. Let's make it a quick 4-minute lesson. Okay. So now, a unit circle is really not a trick question. It's as it implies, it is a circle with a radius of 1. Its origin is going to be at 0, 0, and the radius is going to be 1. Now, what are a couple of things we know about a circle? Well, right off the bat, I can think of 3 things. Not sure about you, but I can think of, a circle is 360 degrees. The area of a circle is pi r squared, and the circumference of a circle is 2 pi r. That being said, let's go ahead and draw this circle. And I know I'm a student that loves to ask the why. I ask myself, why 360 degrees? Well, after doing a lot of research, I saw that history doesn't kind of agree with itself. A lot of people say it's the Sumerians, Egyptians, or even the Babylonians in 500 BC. But whatever the origin be, they all have 2 things in common. It had to deal with astronomy, and 2, breaking it down into 360 degrees. And what the earlier civilizations noticed was that the sun had a circular pattern around the earth, and they knew that it took about 360 days for that rotation to take place. So they broke down that circular pattern into 360 parts. That's why the circle is 360 degrees. And now we know that the sun doesn't actually rotate around the earth, it's the other way around, but it's still 360 days. So let's go ahead and draw this. So one full circle, 360 degrees. Sorry about that. I apologize. There you go. Now, what's half of 360 degrees? 180 degrees. Great. Now, what I like to do is first break it down into halves. After that, break it down into fourths. Between 180 and this is also 0 degrees, 180 and 0 is 90 degrees. And between 180 and 360 degrees is 270 degrees. Now, after I've broken my unit circle into fourths, I can now name my quadrants. Now, if you don't know this, starting with this side, this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. And I'm writing these in Roman numerals. So, now in quadrant 1, let's do the whole unit circle. After I break it down into quarters, I like to break it down into thirds. Let's look at quadrant 1. If we break quadrant 1 into thirds, we get this point, and this point. So we know this is 90 degrees, and a third of 90 is 30 degrees. So we went from 0, 30, then a third, 60, then 90. And I'm going to go ahead and count by 30s all the way around on just the thirds. So we have 30, 60, 90. What's next? Yep. 120 next. 150, 180, 210, 240, 270, 300, 330, and last but not least, 360 degrees. Now, we got the quarters, we got the thirds, there's one more left, and those are the halves. Now, half of 90 degrees is 45 degrees. So, we're gonna count by 45s. 0, 45, 90. Let's see how good we are. What's 90 plus 45? Yep. 135. Now keep going. So 0, 45, 90, 135 plus 45, 180 plus 45, 225 degrees plus 45, 270 plus 45, we have 315 degrees. Finally, plus 45, we're back at 360. Now, that is the entire unit circle in degrees. Now we're gonna move on to radians, and there it is. No! And you might think to yourself, now we know where degrees came from. What about radians? What is this radian thing? Well, let me show you. Have you ever wondered what degree you get when the radius is a certain number and it's equal to the arc of the circle? And the arc is just a part of the entire circumference. So right here, where the radius is some length, r, and it's equal to the arc with some length, r, we're gonna call that 1 radian. So that angle right there is 1 radian. Now, what we want to find out is how many of these radians are on one full circle. Well, let's use proportions. We know 1 radian is equal to an arc length of r. So how many arc lengths are there in a full circle? That might be a difficult question, but let's try to break it down in a simpler term. Think of a Hershey bar. This Hershey bar has 8 cubes. I want to find out how many of 2 pieces can I break in this 8 cube bar. You can simply do 8 divided by 2 and you get 4. You can have 4 2 pieces. So that was the whole 8 divided by the parts 2. So the whole of this circumference, remember, is 2 pi r. So we're going to write that down right here. 2 pi r. Now in this case, we had, let me switch up the pens. Thank you for being so flexible. We have, for the whole, 2 pi r. Over here, our whole was 8. Over here, our part was 2. Over here, our part is r. Wow, you're smart. You noticed something. The r's cancel out. So 2 pi r divided by r, we get 2 pi. So there are 2 pi of these length radius on their circumference. So that's where you get 2 pi equals 360 degrees. That sound familiar? Great, perfect. Now, let's hop into radians. Now that we know that 360 degrees is the same as 2 pi. So, 360 degrees equals 2 pi. Let's use pink. Different color. So 360 degrees equals 2 pi. Now, same thing as before, cut it into halves. Half of 2 pi is simply pi. Now we're going to cut it into quarters. Between pi and 2 pi. Yup, pi over 2. Great. And now between pi and 2 pi, well, here's something that makes it easier. 0, 1 over 2, 2 over 2, which is just this, and then 3 over 2. So 3 pi over 2. And finally, 4 pi over 2, which is 2 pi. So now for our quarters, we have 2 pi, pi over 2, pi, and 3 pi over 2. Now that we have our quarters, let's hop into our thirds. Now for our thirds, it's the same thing as before. For 90 degrees, a third of that was 30. What's a third of pi over 2? Well, to make that simpler, to find by a third, you want to divide by 3. And remember, dividing by 3 is the same thing as multiplying times 1 over 3. So pi over 2 times 1 over 3 is going to give you pi over 6. And now we're going to be counting by pi over 6. So we have 0, pi over 6, 2 pi over 6, which simplifies to, pi over 3. Then we have 0, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which simplifies to 2 pi over 3. That was 4 pi over 6. Now we have 5 pi over 6. Great. 6 pi over 6. 7 pi over 6. There we go. And after 7 pi over 6, we have 8 pi over 6, which simplified to, looks like this pen is running out. Thank you again for being so flexible. So we had 7 pi over 6. Now we have 8 pi over 6, which simplifies to 4 pi over 3. After that, we have 9 pi over 6. After that, we have 10 pi over 6, which simplifies to 5 pi over 3. After that, we have 11 pi over 6. And last but not least, we have 12 pi over 6, which simplifies to 2 pi. After we have the thirds, we want to go ahead and take care of the quarters. Let me get this pen working. There you go. Now for the quarters. Now, a half of pi over 2, remember, multiply times 1 over 2, you get pi over 4. Great, nice job. Now we're going to count by pi over 4s. We have 0, pi over 4, 2 pi over 4, which simplifies right there. Now we have 3 pi over 4, then 5 pi over 4. I'm sorry, 3 pi over 4, 4 pi over 4. Thank you for catching my mistake. Now we have 5 pi over 4. After that, 6 pi over 4, 7 pi over 4, and last but not least, 8 pi over 4. So now that we have our full unit circle, is it really efficient to be drawing the unit circle like this? I'll leave that up to you, but I've come up with a simple pattern. I'm not gonna say I've come up, I'm pretty sure you've noticed the pattern as well, and so have many people, but this is the pattern that I use to draw the unit circle. First, I start off with the quarters, the easy ones. So we know that this is 0 or simply 2 pi, the full unit circle, right? Half of that is pi, half of that is pi over 2, and pi over 2 plus pi right here is 3 pi over 2. Now, I know they're all going to be fractions, and on the numerator of each, you're always going to have pi because we're dealing with radians. So I'm just simply going to draw pi over and blank for everything else. After I have that, this is the pattern that I have noticed. So on the denominator, it's going to go in a pattern of 2, 3, 4, 6. So here's a 2, 2, 3, 4, 6, 2, 3, 4, 6, 2, 3, 4, 6, 2, 3, 4, 6. Now on the numerators, in the first quadrant, you leave it alone. In the second quadrant, this is what I think. So leave it alone, 1 less, 1 more, 2 times minus 1. And this is what I mean. So remember we had pi, so this is done, you leave it alone. Over here, you want 1 less. And what I mean is the denominator. So the denominator is 3, 1 less is 2. Over here, 1 less than 4 is 3. Over here, 1 less than 6 is 5. Now over here, remember I said 1 more. Denominator, 1 more than 6, 7. Over here, 5, then 4. Over here, you want 2 times 3, which is 6 minus 1 is 5. Over here, 8 minus 1 is 7, and 12 minus 1 is 11. And another thing I've noticed, if you look at the angle, well, the radian measure, directly across this and you add the numerator and denominator, you get this numerator. So 5 plus 6 is 11, 3 plus 4 is 7, and 2 plus 3 is 5. And that concludes the lesson on how to draw the degree and radian measures on a unit circle. Hope you learned a lot today, and remember, practice. Bye.